So I'm a quality assurance engineer at the NASA Jet Propulsion Laboratory. And basically our job is to make sure that everything's built the first time, because once you get on Mars, there's no tow trucks. So you can't fix anything later on. So that's the short version of what I'm doing now and where I work. And we're always trying to figure out how to do things better, how to have fewer problems, and how to do it with fewer taxpayer dollars, because, you know, I pay taxes too, and I don't want to waste any money. But I'll let you ask whatever questions you want to ask.
Yeah. So Jordan, you said you're a quality engineer. That kind of tends to be a sweet spot for folks who, you know, graduate with some lean information and background, right? So quality is a lot of times the home for Lean Six Sigma. What's lean about your job as a quality engineer at JPL?
Yeah, so generally with Lean Six Sigma, at least well, maybe I shouldn't say as I learned it, as I understand it, is you're trying to do things, when you say you're trying to do things leaner, you're either trying to do it faster, you're trying to do it cheaper, or you're trying to do it with fewer errors. Generally, you want to go faster, better, and cheaper. You want to go all three, but we all know that it's kind of not necessarily all three. So at JPL, it's kind of weird how we apply it, right? So to give you context on what JPL is, so you probably have all heard of NASA, I hope. If not, I have some concerns for our PR department. So we're NASA does all the space, we do aeronautics, we do lots of research all over the place. We have robots going everywhere, we have humans going everywhere. We have a bunch of different centers that each specialize in different things. So JPL, the Jet Propulsion Laboratory, we're the facility that's in Pasadena in the LA area. We specialize in deep space robots. So Mars rovers, the Voyager spacecraft that have left the solar system, Earth science and climate change research satellites, all those robots that go all over the place that people can't go those places yet. So one of the things that makes us unique is that we only ever make something once. So generally, if you're working at like a packaging company or a bottling company or something like that, you know, they'll make 1 million cans a day or what have you. And the Six Sigma that they're doing is trying to make it so that's only 0.0 whatever % of those cans have a dent in them. Well, a lot of Six Sigma just doesn't apply for us because everything we do has an n equals 1. We only have a sample size of 1. Statistics are effectively irrelevant when what statistics are you going to do when you don't have multiple of an item? So we still do, it's really hard for us to do Six Sigma because we never do anything twice. So what statistics would you do? So we do a lot more lean. So we are heavily concerned about schedule constraints because we are actually constantly fighting the laws of physics. You know, usually if you have like a marketing project at some company, if the product launch is delayed by a little bit, you know, you might miss all the Christmas scales, and that's a huge deal. For us, if we miss a launch date, the laws of physics dictate when the planets literally align. We can't just do it the next quarter. We sometimes have to wait years before the next launch opportunity. So it's really critical that we launch on time and are ready on time because we don't get to choose when we launch. Physics does. We're also very concerned about the resources that we consume while doing so. You know, space travel is expensive, although honestly, we're a pretty small part of the federal budget, if you ask me. So we're taxpayer funded. So we're always trying to be cognizant of those taxpayer dollars. We're always trying to be as good a custodians of that as we can, because the more efficiently we can do things, the more exploration we can do, the more science we can do. So we focus a lot on the lean of figuring out how can we remove waste from our processes, how can we figure out how to do things faster or for cheaper or with less people working on something. But the thing we always have to keep in mind is that it is critical that we don't remove too much and have it break. Because like I said, we don't have tow trucks out there. So we can't just try it, see if it works, and then do a recall like a car company does. If it doesn't work, that's the end of the multi-billion-dollar mission. So yes, we're trying to do it faster. Yes, we're trying to do it for fewer dollars, but we don't want to do that at the cost of introducing too much risk. We're always gonna have some risk, but we don't want to have too much risk. And it's a fun balancing act, and I'm gonna stop rambling now.
So yeah, that's interesting. So you've got this sort of quality priority, even though you're trying to address like all the things that lean tries to improve. So Jordan, can you tell us about maybe a current lean challenge? What's you just launched something? You got something else getting ready to launch, or what's going on?
Yeah. So I'll give you a good contrast here. So there are two main projects that I work on. One project that I've actually spent most of my time on is Europa Clipper. It's our next Jupiter orbiter. Here, I have another background for that one. Huzzah. Okay, so Europa Clipper is this big guy. It looks rather small. It's actually like massive, massive, multi-football field massive. So it is going to Europa, one of the moons of Jupiter. It is an incredibly sophisticated mission. It's tying together partners and universities from across the country and even across the world. It's one of those once a decade big flagship missions that JPL does. We have an incredibly low risk tolerance on this. So we check every single tiny little thing you can possibly imagine because we really don't want to mess anything up because it's going to such a crazy environment. It's such an important mission. We can't take any chances with it. The flip side of that is I also work with a lot of our smaller, higher risk tolerance missions. So we have technology demonstrations where they're just trying to prove that something was physically possible. And as long as it does it like once, it's fine if it doesn't last more than a week on the surface of Mars. We have ones that are small CubeSats that are very standardized parts. And so they can take a little bit more of a higher risk tolerance because they've already proven that it's worked over and over again with different parts of industry. We don't have to try every little thing ourselves. I don't want to get too far into the details on it, but basically we'll treat projects differently depending on what their needs are. So Europa Clipper, big, expensive, has to work right, almost no risk on that one. Small ones that just need to try it, we'll take a higher risk tolerance on it. We'll actually choose not to inspect certain things. We'll choose not to verify certain things. We'll choose just to accept a higher risk because we can get more of those demonstrations all done for the same budget if we're willing to accept a little bit higher risk on each one individually. And because it just needs to work for like a day or a year instead of working for a decade, it's okay to do so. It just depends on the needs of that specific project.
Yeah. So Jordan, I want to encourage our students to type in the chat and let's see. So I see Kaylee's asking me to make her a co-host. Kaylee, you want to go ahead and pop on a second so that your name jumps to the top. There we go. And I will make Kaylee a co-host. There we go. And now I got totally distracted as to where I was going to go with my next question. So there you go for that. Oh, I know what I want to ask you. So and I want to encourage the students to also ask questions. So if you got a question for Jordan, go ahead and type it in the chat, and we'll go ahead and ask you to come on live and ask your question. So you were in this class, you know, years ago or back in the day, I guess we could say now, and you learned certain, you know, how in this class we teach certain tools and things. Are there certain go-to tools that you like? I know you got this big sort of risk quality imperative, but you know, are there some basic tools that you found that were pretty useful from your time in this class?
Yeah, it was really important to learn all the tools so that I knew what options existed and so that I had a common language to speak to people with. But in reality, I don't use most of them on a day-to-day basis. I use a lot of the concepts a lot more. So for example, probably the thing that I'm doing the most right now that I just embrace full on is Gemba. So, you know, I don't use the word Gemba when talking to my coworkers, I just do it. I'm very big on, you can't actually improve a process until you've actually seen how the process works. It doesn't work if you just announce the changes from yay on up high and just tell everyone below you, do this thing. Well, it's not going to work because that's not actually how they were working on it beforehand and you misunderstood. And B, they're not going to want to listen to you because why would they? So as we're developing a new software tool or as I'm writing new requirements and rules documents, I go and I run through the process myself, sometimes for months, doing those jobs myself, because that's the best way to understand how it actually should work. And you always work with people who actually know that best. You're always having this feedback loop. If you can, Gemba and do it yourself. But or actually Gemba is just talking to them. I say go a step beyond and do it yourself. But yeah, Gemba was huge for me. Just the more you can actually see it yourself, the better it'll be.
You know, I find too, besides from that seeing it yourself, there's also like an empathy that develops, right? An appreciation that you maybe wouldn't have. And I think you get a lot of that when you actually do it yourself. Let's see, Kyle, Scott, you got a question for Jordan? Why don't you pop on?
Hi, I was just wondering what your favorite project is that you've worked on at NASA.
I'll switch back. So, well, this is actually curiosity, but I worked on the Perseverance rover that just landed on Mars a few months ago. I only did spend a little bit of time with it, but I was doing inspection work on some of, they called it the lubricated mechanisms for that sample catching system. Basically, I got to hold things in my hands that are now on the surface of another planet. And that's just amazing to me. I know I grew up looking at Mars rovers, that was the most incredible thing ever. That was the Apollo of our generation. And then I got there and I got to actually work on one. I got to actually touch one. And now a part of something I've worked on is on another planet. And that's amazing to me. I'm really excited about Europa Clipper, this one I'm working on now. Europa is one of the best places to search for life in the universe or in our solar system, but it hasn't launched yet. So I'll stick with Perseverance for now.
Okay, very cool. Hey, Ben, you've got a question for Jordan. Go ahead.
Yeah, so I was just wondering, like having come from Cal Poly ITP program, which is part of like the sort of quote unquote business school. And people would typically think of going down like a businessy route, you know what I mean? So how did you end up going down the career path you did with, working with jet propulsion labs and stuff? That's cool.
That's an excellent question. That one actually took me a bit of work and a lot of substitution requests from Dr. Olsen. It's more about how you paint it. So part of it is understanding what exists under the category of engineering, and part of it is understanding that you're actually capable of a lot and how to sell it. So the first part of that was what's engineering. One of the things that I didn't understand at the time was when I was in ITP, I was like, okay, well, I'm business. We're not actually business, we're ITP, but I was like, I'm business. I didn't have the calculus classes that they did. And then I looked at the engineers, I'm like, oh, they're engineers, they do engineering. And I realized that I actually totally misunderstood the field of engineering. So what I thought of was engineering was, the mechanical engineer sitting there designing things in SolidWorks all day. That is one type of engineering. That design engineering is one kind of engineering. Industrial engineering is also engineering. Process engineering is also engineering. Systems engineering, a field I didn't even know existed when I was in ITP, is also engineering. And all three of those are things that ITP majors are qualified to do. We don't design hardware, we design the processes that produce the hardware. We design the organizations that produce those processes that produce the hardware. We look at how everything fits together. We're not the experts in one thing. We're good at having a whole bunch of different types of engineers all talk to each other. That's systems engineering. So I was a lot more qualified for it than I thought I was. And then I had to figure out how to sell it to places. So you've probably already run into, when you talk to a lot of companies, they'll be like, well, but you're not actually engineering, right? Are you a mechanical engineer? And you're like, no, I'm not a mechanical engineer. And they just don't understand what to do with you. So selling is a big part of it. For my part, every internship that I got, I interned at JPL, SpaceX, Procter & Gamble, a local machine shop. Every one of those I got through Career Fair or Polypack or a local friend. I was rejected from everything I ever applied to online, even once JPL was already on my resume. Because I had to explain it to them. And one thing that I found is that, we don't fit neatly in the category of mechanical engineer or civil engineer or accountant or whatever you think it is. We're that niche. So one thing that happens is you got to go talk to a lot of people and you got to learn how to sell yourself, which as ITP, fortunately, you have training in how to do so. And one thing that you'll find is that most people will have no idea what to do with you. But the ones who do, you will be the only one applying. So in my position that I have now, they basically created the position for me because there was no one else who had the combination of engineering, business, some actual political science background that I have as well, and then just raw passion for space that now I use every one of those skills every day in my job. And they have to constantly try to teach engineers how to speak better or teach business people how to do engineering more. And I already could do the mix of those. So there was no one competing with me, but also no one was at all interested in me until this one group. Right. So it's tricky, For me personally, I knew I wanted to go more into engineering than ITP did offer. So I went and did a master's in IE. Honestly, that was more because I wanted the credibility of that than actually anyone's expecting that of me. JPL would have hired me in this position with or without it. That was just something I chose to do personally. But yeah, it's a hard problem to solve, but it's also, it works out really well once you do, and you will.
Right. Well, thanks for the answer. That was a
Yeah.
good answer.
Yeah, thanks, Ben. But Jordan, I wanted maybe, take Ben's question and move it in a little slightly different direction, right? Because a lot of people in this class are not ITP students, right? This is a, technology management required for business students. Do you have advice for, maybe accounting or management students who want to take a step in that technical direction? Have you sort of seen that sort of move in your experience at JPL, or they're pretty engineering intensive still, even a few ITP folks through the door there, right?
We definitely have ITP folks. One of our interns right now in my group is actually a current ITP student, and I've worked with other people in my group who are ITP grads. We definitely, we don't exclusively recruit from Cal Poly, but I think ITP grads do a pretty good job, and we do end up recruiting some of them. We do have people that come from a mixture of backgrounds. One thing that you'll find people constantly tell you once you get way past in their career than I am, like way older than me, is that, pretty quickly out of college and significantly after a little while after college, you kind of just do things that are completely unrelated to your major. So for example, the project lead that I work for right now, incredibly technically excellent, great guy to work for, one of the best engineers I've ever worked with. His bachelor's degree was in English. But he went and he did a whole bunch of work experience in machining. He went up through that route. He did end up getting a master's degree in engineering related field. And he switched over. So switching over is absolutely a thing you can do. ITP has this funny median where you kind of already do both, and it's just a matter of selling it and figuring out that niche. One thing I will say for the non-ITP majors in the class is if you want to get technical and you get into engineering, you probably will need to go develop some of those more of those skills, probably through work experience. But when it comes to the lean part of it, that'll be useful no matter what job you're doing. So like I said, I'm probably different from a lot of the other lean celebrities that you had in this class, where they're talking about, here's the tools I did, here's the big DMAIC project that I did. I don't do most of that stuff. We just take the principles and apply it where it seems relevant, because our stuff's kind of weird. You can do the same in every industry. So in your accounting field practice, in your legal practice, in your marketing practice, whatever you're doing, even if you don't use the word Muda with someone, even if you don't use the word Gemba with someone, even if you're not doing a statistical process control chart, the concepts of lean, the idea of continuous improvement, the idea of asking experts for help, the idea of constantly trying to make things better, that applies everywhere. It's the mindset that's really critical, and that's going to be good no matter what job you do.
Let's see. So we've got a question from Sunmi. So if you can go ahead and pop on and ask it, and we're going to make this the last question, and we'll go for the wrap up here. So Sunmi, go ahead and ask your question.
Of course. Thank you so much, Jordan, for coming today. I wanted to ask a question just about your experiences with Lean so far, since you've been working as an engineer, or even before you got your current job. Can you tell us one good experience, something you used to lean on that went excellently well, or something you used to lean on that went the opposite direction?
Honestly, I don't think I've been in my career long enough to have had any major screw-ups. I just haven't had time to mess up that badly yet. I'm sure it'll happen, guarantee it. I just haven't had a chance yet. I would say probably the thing that the biggest mistake I've made so far was scope more than anything else. So one thing you'll find when you're trying to do continuous improvement is your job is to go look for problems and try to fix them. And so that's very, very easily gets out of hand, and you want to go boil the ocean and fix the entire world. Or even just fix a couple problems in your group, and all of a sudden they explode out of scope. You can't actually get anything done, and you're there 2 years later saying, well, we made some progress. So for example, that higher risk tolerance projects, the process improvement that I do with them, I started working on that project in one of my internships in 2018, and I'm still working on it. And I definitely thought that I was going to be done in a few months. Clearly that didn't work out. Defining a small scope, defining exactly what you'll be delivering, that's actually a really, really important skill that I'm still developing. And that's probably where a lot of my problems have happened, because it's great if you do all this cool work, but then if it never actually completes, then it never gets implemented. And then what was the point? And so the benefit of continuous improvement is not to constantly have this open project. It's to have small project close, start a new small project, have that close, start a new small project, and keep doing that. So at least it keeps entering actually production. It actually keeps getting used as you're going, instead of like, well, we're going to work on it, and then a year from now, finally, we'll maybe get something, or it won't work at the last minute. We just wasted a year. Probably the bigger successes I've had, I like the Greenbelt project, I was able to do some things. My SpaceX internship, I was able to increase the reduce the amount of time it took for them to pick inventory out of the warehouse by like 9%. And yeah, you can do that. But at this point in my career, having been full-time for like a year and a half or so, probably the biggest success I've had is just being able to build credibility. I've become someone who actually can do things and wants to do things and is willing to work on things, and it'll actually deliver things well, and it has shown that I'm somewhat competent and reliable. And when I see problems, I go address the problems, and people come to me to try to help solve the problems. And building that credibility is probably the most important thing that I've done. That's going to serve me for years and years to come, because you don't start out at the top. You start off doing the grunt work, because someone's got to do grunt work, and that credibility is going to be the biggest asset I have.
Absolutely. Thank you so much.
So Jordan, it's been really nice chatting with you once again. You tend to be a frequent celebrity on here, and I'm glad of that, because I think you bring a sort of energy and perspective that, as you say, we don't always get from some of the other lean celebrities that we have. But as we sort of always do and sort of wrap up, I want to ask you, what piece of advice do you have for all these new to lean students that are going to go off and hopefully start on really cool lean journeys, kind of like yours? So what piece of advice do you have?
Honestly, I think the questions they asked stole the advice I was planning to give, because the advice that I give is really, you're going to use this information. You may not use the Japanese words, you may not use the specific tools. Honestly, I've forgotten half the tools, let's be real. What you will use is the mindset. What you will use is the credibility that you build by having these skills. What you will use is the understanding of how to navigate across those squiggly career paths, because most people don't actually do ladders anymore. That doesn't happen. You go squiggles and you go wherever the next opportunity is, and that's great. That's actually not bad. So keep in the mindset of continuous improvement is great. You need to you need to understand these tools. You need to learn this basic knowledge, because you need to have that credibility and that common language. But the mindset will be really critical no matter what you're doing. And I highly recommend you use it and spread it. All
right, Jordan, thank you so much for this. As a sort of parting gift, I'm going to ask everybody to turn on your video. Give Jordan a little Zoom wave and appreciation and thanks. We'll get this on the video recording. So we'll see you later, Jordan.